Hey, how's it going, everyone? This is not a presentation. I just wanted to repeat that again. But I was going to just put up the list of features. It says already released. This is actually a slide deck that I was kind of like maintaining to like during the release process. I actually have not looked at it in a couple months. I don't know if it's actually updated. So I'm not planning to actually switch to it unless we have specific questions or whatever, but I've got these 2 slides of features which are kind of in the order that we released them. So I thought maybe we could just open this up for questions, and then we run out of questions on these topics, we can move on to the other half of the features. So just to give you a thumbnail on each of these, and the release notes are a better place to look probably for the details of those things, but one of the first things we worked on was efficient drop and partition for algorithmic collections in particular. And so just this idea that a lot of times you have a sequence or something like that where you want to pull chunks of work to do at a time. If you just generically have sequences, then you have to walk through each element and then build a new chunk. So there's the taking, and then there's the thing you have left at the end. And so partition gives you a way to get all of a sequence into partitions, but you're going to get, it's a lazy thing. So that's one sort of solution that you have. You can also do take 10, drop 10, something like that. And then there's some variants like split and split at and things like that. So the downside of that is that you have to walk it as a sequence and to get to a thing that is still a sequence at the end. And for certain kinds of collections, like if you have an index collection like a vector, or if you have something like a range or repeat or cycle, something like that, you can more efficiently do that work, right? And so there is now an internal interface called iDrop, which is a fun name, and all of those algorithmic collections like range, repeat, cycle, and then some indexed type collections like vector now support those things. And so they allow you they're basically, I am a thing that is able to give you a chunk of things and also give you back, if you drop, you get back something that is of the same type you had originally, not a generic sequence. And so it has that ability to keep doing that work over and over again. And there's some new functions that sort of use these automatically. We actually modified drop and interest and interest. I can't remember all the ones we changed. We changed several things that do this kind of work, and then added new functions that give you vector partitions instead of seek partitions, which I don't think we ever really commit to returning you seek partitions in the doc strings, but we were worried that we would maybe be, if we changed those, that we would be changing some behavior, so we didn't. We just added new functions. So that's in there. It does make certain things that already, some existing code will just be faster as a result of this. You can also use those new split vadd, partition v all. There's some new functions there that can give you a little bit different behavior too. Are there any questions about that? No. Okay. VAR interning. Do you want to take a shot at VAR interning? Folks did most of the work on that. We didn't introduce ourselves. I'm Alex Miller. Probably most of you know me. But Michael Fogus, Jared Taylor, we all work with Rich. Rich isn't here yet, but we're still working with Rich quite regularly. There you go.
Yeah, so the VAR interning was a nice experiment that we had found out that we'd come across this problem in compiled code where we were hitting. Jeez.
It was with abs in 111 is where we saw.
Yeah, absolute value, right? Yeah. This we were running into this problem where the VAR was disappearing out from underneath of us, and
well, I think we ran into it through fast math, which redefines or adds the abs function. And so if you already had, and so we added abs to core, and so we were adding a new function that already existed for some people in their namespace coming from some other namespace. And if you were in already compiled code and then switched to using 1.11 that already had this, there's like this sequence of things with the way the namespace loads,
Yeah.
right?
Yeah.
And it's complicated.
Yeah. And the hard part is to fix it so that it didn't break existing code. I mean, we're always trying to avoid that problem, and so vars by experience had a certain policy that people were trying to that we tried to adhere to, but it was never explicit in the code, and so a lot of effort was done in trying to define what the var policy is. And I think one of probably the biggest policy for vars that we had defined and reified in code was the idea that there's this namespace intern var, and the namespace intern var is something that the name itself matches the name of the var, and so those vars cannot change. They can never change, and so.
They're intended to be stable references.
Yeah, they have to be stable, and so we've now locked that down, and so by doing that now we have some guarantees around that, and so you can still run into problems, but not with these namespace intern vars, and so trying to lock that down and define what that is and get that fix the code around the interning was really a lot of work, and a lot of thinking had to go into that, and it was complicated.
We found at least one fix that had been done in this area in the past that had fixed one symptom of this, which as we went back and looked at it, we're like, this was the wrong thing. So we actually undid some previous changes in tandem with making some changes in namespace. So yeah, it was one of those things that most people, I'm sure, didn't even notice anything about this. But
well, that was the goal.
That was the goal, yes. Yeah. The next 4 items here, oh yeah, go ahead, sorry.
For those looking to replicate this policy, aside from being in the release notes, which I will check, is this policy also now documented as part of the Clojure docs?
Yeah, there's some. I took some time to write some code documentation around this, and so I think that in the code itself around namespace interning, there's a table that describes the different kinds of vars, the namespace intern vars and the non-intern vars, and so that should be a good guide for replicating this behavior.
And we updated the reference docs on the website are updated with the policy kind of stuff, so we tried to surface that too. Yeah, if you have, and there's obviously one Jira for this ticket, which has a patch, which is the changes that we made, so that's also a good place to look for stuff.
It'll be the only documentation in that file.
Yeah.
If you're looking for it, it's the one.
It's the one doc string, yeah. The next 4 are all really part of AdLibs. So AdLibs is a new feature for interactive programming that we've had in sort of a very alpha form for a long time through tool steps, and other people built versions of. And way back, we had an I can't remember, there was a function still in core that's deprecated that did something very kind of similar to this in some ways. But the goal here was really to enable you to dynamically add libraries at runtime in the REPL. And so you can use adlib, which is the new function. That's auto-referred in your REPL. It comes out of Clojure REPL deps, but adlib, adlibs, and sync deps are the 3 sort of public APIs for that. And the basic idea is you can add a library using a depseedn style dep in the REPL. The coordinate is optional. It will try to find the newest version of that we're subject to what Maven or Git thinks is the newest version in that regard. So that's not necessarily guaranteed, but you can provide a coordinate if you want. So you can say something like adlib clojure.data.json, for example, and that will pull that, go download dependency if it's not already been downloaded. It will find the newest version, download it, add it to your class path at runtime, and then you can just start using it. And so the goal there is really you shouldn't have to restart and lose the state of your REPL to keep working. There's a whole stack of things here that we needed to do. To use tools deps to do all of that class path resolution, just like we do in the Clojure CLI, we didn't want to levy all of those dependencies, of the dozens of dependencies needed for that, Maven and all sorts of stuff, onto your REPL at all times. And so the big change here is that we're calling out through the Clojure CLI to run that program externally, and then bringing the data back, the library to download and all that kind of stuff through a tool invocation. And that seemed useful, so we actually made an API out of that. That's in tools.deps interop or something like that. So that allows you to invoke external tools. To invoke something external, we needed to use a Java process. There is an existing API for that in Clojure Shell or Clojure Java Shell. I can't remember which one it is. But that one didn't take advantage of a lot of the newer things that were that are available in the new process APIs in Java, especially I/O control. And Babashka.process had done some work on trying to make an API around that. And so inspired by that, we made a new process API, which is in Clojure.java.process. And then to know sort of what your running class path is, we need we call the runtime basis, which is really the class path and the libraries that built it. The Clojure CLI injects that into your process through a system property. And so we made an API to get to that. And so there's a whole stack of things here that seemed generally useful that we solved in service of ad libs. So that stuff is all in there. Yeah.
That all sounds really exciting and well thought out. Talking about this external functions invocation API being a potentially useful thing, have you heard of people using it for things other than ad libs?
Yeah, so the question is whether the external function invocation has been used elsewhere. I have seen a few people using it. There's a lot of you do have to use it very specifically. So there are some things to know about that. There's actually a whole a function invocation API for Clojure CLI tools, which is documented on the CLI reference page, but I think most people have not seen it. And I know that no one had used it because it was wrong. So we discovered that recently. The docs have been updated, but some of those were definitely out of sync. And I would like to do a little more sort of show and tell about that stuff, but I haven't had a chance yet. Yeah, Sean?
Yeah, we're using it because we're actually running tools from build CLI file.
Right.
Yeah. A question about sync deps, because my workflow with this is I edit my deps file, add a new dependency, and write on sync deps.
Mm-hmm.
And at some point, probably in early alpha, I ran it with an alias that had a huge set of deps, and it broke. I think it hit like a command line line.
Yep, we fixed that.
It did get fixed. Okay.
Yeah.
I haven't tried to reproduce it, and that's what my question is.
I have tried to reproduce it, and it's fixed. It was tested with your example, in fact, along with other things, but yes. Yeah. Jay?
You mentioned that there's ad lib and ad libs.
Yes.
The Clojure team is very intentional about API design. I'm wondering why you both.
So I think the common case is ad lib. Like I just have one thing and I need to add it. And the thing is that is bringing in multiple dependencies under the hood. If that's got transitive depths, it's going to bring in whatever things are not in the tree but not in the class path, basically. When you're doing resolution, sometimes it matters if you're doing them one at a time or if you're doing multiple at the same time. So it's a pretty subtle difference. So ad libs is sort of the more generic case of it. Like here is a set of libraries and coordinates. Resolve those in combination with your existing set of libraries and coordinates, and you might end up with a different version of a transitive dep in particular when you do that. That's pretty subtle. Most people are not going to care most of the time, so adlib is sort of the common case. And then we made the coordinate optional, so it can be really pretty small. So we poured a little easy on the end of the simple thing, but yeah, Colin.
Does all this lib wrangling work with like in Ripple, and to what extent does any of this work with Lightning?
It's a good question. So it does work in REPL. It shells out and uses the Clojure CLI, so you need to have that running, obviously. And there are some little differences with how the REPL starts in different environments, with what you get auto-referred into your user namespace. So like the Clojure main REPL does one thing. I think maybe nREPL does something slightly different. They've got their own version of that. So you might not get that auto-referred. You might actually have to require Clojure REPL deps to get that. So there's some minor differences there. The big thing that's different with Leiningen is that the Clojure CLI is injecting a system property that defines the basis, and Leiningen isn't. Jared built a tool that lets you bootstrap that in the REPL. So it's a, I don't know, you describe it. I forget now how it works.
Yeah, it's been yeah, there's a Leiningen tool, so it is a tool, and you can invoke it just once to bootstrap it, and you'll get the basis file, and then you can use adlib and adlibs like you would otherwise.
So that bootstraps the basis from your Lightning devs, does it?
Yep, yeah, it uses
It builds an equivalent basis that's
Yeah.
the same thing,
Yep,
basically.
it uses Leiningen to do that and build that.
Yeah.
And that obviously sync deps doesn't work with a Leiningen project, but adlib and adlibs do. Yeah.
Sync deps could potentially work, but we haven't done that work, so patch is welcome. Yeah, and that's we built that. That's a New Bank project because we use Leiningen extensively at New Bank, and so that was important for us to give that reach to people at New Bank. But obviously also useful to anybody using Leiningen, so we open source that. But we'd be happy to take contributions on that too, I think. So, any other questions on adlib stuff? Has anyone been using adlibs? Adlib, sync deps, any of those? Cool. That's good to hear. When Java 21 came out about a year ago, is that right? Can't remember. One of the big features in Java 21 is virtual thread support. And one of the things that they did not have done yet in Virtual 21 is support for parking and swapping out context if you're holding a synchronized monitor. There's really actually at least three cases that I know of, which is synchronized monitor, wait notify, and there is a very stealthy monitor underneath class loading because there's a guarantee that the static initializer runs exactly once. And so there's actually a lock there under the hood. And so that also, if you happen to be running the static initializer, you can't swap out that thread. All of those things are now being addressed have been addressed in Java 23. Is Java 23 out yet? I think it's out. I think it just came out, or it's about to come out. I can't remember which now. I can't keep it all straight. So they have subsequently backfilled that support. But there are a couple things in Clojure that hold a lock in the implementation while arbitrary user code runs. And those things are seeks, which have a lock, a monitor around evaluating the next node in the seek, a lazy seek in particular. And then delay is the other big one that has a once and only once kind of semantic that was guarded by synchronized. And so because of that, that meant if you were using those things in Clojure in a multi-threaded program with virtual threads, it was potential that you would actually block a virtual thread and the carrier thread underneath it, and you would see events happening in the JVM for that, and potentially that could cause a problem. So we looked at a bunch of ways to potentially solve this. It was really subtle. It made us a little bit upset that they hadn't actually fixed this problem in the JVM, because it seemed like you were really levying an extra cost on people who use synchronized, which has been part of Java forever. So We thought that was not a great look, but anyways, that's what they did. What we ended up doing is basically replacing the synchronized use with read-write lock, or maybe it was read lock. I can't remember now which exact flavor we used of that, but we used the built-in locking support instead of synchronized, and that was supported in Java 21 with support for parking and all those kinds of things. There is the trade-off there. The main trade-off there is that class is an object, and you have to have one. So it is new objects that did not exist before, and there's one for every node in a lazy seek. So if you do a lazy seek that's 1 million items long, there's 1 million locks there. And so that's 1 million lock objects that didn't exist before. They do exist ephemerally. They're just created, used to reify the next thing, and then the references are removed. So they can be removed as garbage, and the JVM is exceptionally good at removing ephemeral garbage like that. There can be impacts here with memory use and with GC load. We haven't seen a lot of that internally at Nubank, but I'm interested if people observe things like that. I would love to hear more about that. I haven't heard any, I don't know, have any known issues with this, but it's something that could potentially be different between the two. So, yeah.
I was wondering, is it probably too much for here, but is there a pointer to some reference and discussion about why it wasn't just postponed for the virtual thread support until that stuff got fixed, rather than doing something?
Well, so in general, like the Java team has moved to this tip and tail model, they call it, where they're sort of eagerly putting out features as they're available, using preview features in some cases that you have to enable, and then letting people and then backporting stuff to older versions. That's the tail part of it, so that you don't have to move if you don't want to. And so in general, that means that most things get either come out in preview or they wait until they're done. In this case, I think it was deemed really important, and they didn't put it in a preview, they just made it a feature. And so I assume that's a product management call in the JDK team.
No, I was thinking on the Clojure team side that
Oh.
changed the.
We didn't know how long it was going to be until they supported it, and we had people who were already starting to explore it and were running into these issues. And so we thought it was important for us to move forward. I went to the JVM Language Summit this year, and I talked to some of the Project Loom folks, because my big question was, like, when this gets fixed, do we roll back to what we did before, or do we keep doing what we're doing now? And they surprisingly did not have a real solid answer to that question. They're like, no one has asked that question yet. So, but in the end, after talking to them for a while, they said basically, we think you should continue to do what you've done and use less synchronized. And it kind of correlates with some other changes they're making. They're trying to make objects lighter weight. And so there is a ton of work being done to squeeze the object headers down, and they're doing that in very, very clever ways. There's a great talk from the JVM Language Summit about this, which I'm not sure is out yet, but that's a really interesting talk. And one of the things they're doing is just omitting the monitor until you need it. So like the header for the object doesn't have the monitor information by default. And then the first time you do synchronized on it, it will like upgrade to a fatter object header or something like that. So omitting those things from the lazy seek nodes actually means those objects can be smaller in memory. And so maybe it's not actually that much of a trade-off heap-wise. So they said that was still what they preferred. Sean?
You sound like you're using virtual threads in-house at Nubank.
There are people experimenting with it. I'm not sure what the production level status is with it. Yeah.
Then kind of a question for the room. How many people here are already using virtual threads heavily in production? That's about what I was expecting.
Yeah.
Because we've tried,
Yeah.
and we keep running into problems with various tooling and libraries.
I've heard that. And if you run into problems, they really, really want feedback.
Yeah.
So sending those Loom guys information is super useful. They have a bunch of features that they are putting in that are going into 23 to make stack traces and thread dumps and like managing those things through tools where you can see those things. Like they're working on all that stuff right now and really want feedback.
For us, the biggest obstacle has been New Relic.
Okay, well, yeah.
Which uses thread local
Mhm.
pretty heavily, and we've had complete application lockups unless we disable their instrumentation on certain things.
Yep.
And I've gone back and forth with the New Relic engineers, and they're like, well, if you can't produce a little repro program for us, we can't fix it.
Yeah.
We've never seen this before. So I was wondering if anyone really was using virtual threads in Angular, and I think the answer is no.
No, so there were definitely people at the JVM Language Summit who were using them heavily, and they were experiencing problems. So there was a lot of discussion at the workshop. So, and Thread Local is a tool in the JVM that lets you hold an object value that is a per thread object value. So it's kind of like our dynamic bindings, which are built on top of Thread Local. And so they in some of the early previews, they removed Thread Local support from virtual threads. And what they found was it greatly reduced the number of programs that could run on virtual threads because they're used so heavily in Java. Java frameworks use them a lot. So they eventually gave up on that and said, I guess we're just going to leave it in there and you can do that, but we need a better alternative. And so they created the scope values API for that, which is similar in usage, but different in the way it's implemented. And there's more support under the hood for it so that they can pass those scope values over to new threads in a lighter weight way. So I've done some experimentation with scope values. It's annoying in 21 in that it's a preview feature, so you have to add the preview feature flags to the JVM and do special stuff, and they're still changing the API. It's not final yet. That's why you have to do that. And they're also really looking for feedback on scope values. So if you do experiment with it and have some feedback, they would love that. So we could potentially in the future, some future version of Clojure, host dynamic bindings on top of scope values. And I think that would be a really interesting change. So, yeah.
So let's say time goes by and the virtual threads stabilize. Are there any plans to make updates to core async to let you choose when you're parking? Are you using the current thread pool or virtual threads?
Yes, we're working on it right now. And I was going to talk about it in my talk on Friday a little bit, but so I'll mostly defer to that. But yes is the answer, and hopefully that's something that's out, soonish. And the code changes are not the hard part. It's all of the compatibility, versioning, like figuring all that stuff out is the hard part. So we're trying to
organization.
Yeah. Any other questions on virtual threads? No. All right. What time is it? Are we? 2:30. So we are. Are we at time already? We got another 10 minutes. Okay. Oh yeah. Okay. We're good. So we'll just cover all these giant features. Yeah. Who scheduled this thing? This is crazy. So just quickly to go through these stream support functions. There's so streams are ever more used in Java, and there's no sort of way to bridge into seeks or reducibles or anything like that. And so this is really adding some new things, some new functions that let you use reduce, transduce, convert to lazy seeks, all that kind of stuff. Persistent vector splittrators. Splittrators a that's not new now, but newish interface in Java that is kind of like the partition stuff I talked about earlier. It's an iterator that allows you to say, split this iterator in half approximately and parallelize the work for it, and you can do that repeatedly. And so Java knows how to do this for parallel streams and get faster performance. Persistent vector actually has the easy ability to do this, but we'd never implemented the splitterator for it. So it's just using the default, which is never parallel, basically, or parallelizable. And so this was implementing that interface and giving that flowing that down. So you can now take a vector, pull a parallel stream off of it, and use the Java parallel stream APIs, which is a lot faster depending on what you're doing. So that's kind of interesting. And there are more things I think we can do in this vein, but this was what we took for this one. And then the next 4 features are all really about method values. So the goal there was really to allow us to take Java methods and treat them as Clojure functions. And in the service of doing that, we created this new uniform class name / member syntax that you can use in value position. We also sort of made that also uniform in function position. We needed some way to specify overloads for a particular method, and so param tags is a new metadata form for that. What we ran into then is like a lot of var overloads are array classes. There was no way to say that, and so we made that. So all of this work kind of fell out of that stack of things. And then these last 2 features are really about it's sort of doing the inverse of that. Instead of treating a Java method as a Clojure function, it lets you treat a Clojure function as a Java functional interface. And so that's sort of the big thing is like, if you encounter a case where you have a Java API that takes a functional interface, you can just pass a Clojure function into it, and it will automatically adapt to be the right kind of thing. And it does that by spinning a lambda the equivalent of a lambda underneath it, and uses invoke dynamic to adapt things appropriately. Supplier is a particular functional interface that is a no-arg function. It's not really a function. But what we did was we took IDref and gave it a default implementation through the interface so that it could act as a supplier. So anything that is an IDref, so future, delay, all the reference types, atom, ref, all those things are now suppliers. So you can just pass them as suppliers. And they're not just suppliers, they're also long supplier, double supplier, Boolean supplier, int supplier, so they'll mimic all of those and try to do a cast. If you pass it something that's wrong, you'll get a class cast exception out of that. But you can pass those into any kind of supplier interface. So we got like 5 minutes. Any questions? Yeah.
I'm not actually fully caught up with the method values, but I think it's a improvement that a lot of us are grateful for. I wonder, since you did mention overloads, I think there's syntax for that. If you were to just take like a method value, put it into a var, and then that method has various overloads, can you just through the var make calls to different overloads for that Java method?
I'm going to pass this to Fogus. Let him
So-
answer. It's an excellent question, one that we spent months thinking about.
Yeah, so so the overloads that we're zeroing in on with the param tags, we're trying to get to a specific method, not all of its overloads. We're trying to get to a specific signature. And so if you use param tags to specify a method, you're going to get down to that specific overload.
And only that overload.
And
but
only.
if you don't, then you get something that is, well,
Yeah.
You want to
So,
describe that a little more?
so
It's complicated, but-
if you do not supply enough to get down to a specific overload, we don't specialize. Yeah, if we you can use the underscore to say in any type. So what we're producing is a function that can get down to specific arities, and
it supports all of the arities.
all of the arities, yeah.
And
Basically the automatic, like the implicit lambda wrapping that you said does a dynamic invoke, so
Yeah.
you can actually get to all of those overloads.
Yeah, and it may use reflection at the bottom of any specific arity, or it may resolve to a single method at any one of those arities as well. But we don't fail. When we first released it, we failed if you weren't able to get down to a specific method. But we relaxed that now so that we can use reflection at the bottom if we have to.
And so what we're really making explicitly is a function, an anonymous function with one arity per overload arity, and that call is then making the equivalent, method call that we would have been making, which might be overloaded. If it is, you'll get reflection. If it isn't, then you won't. And if, a new version of Java adds something in, then you also will get, it might become reflective, which is already the case for any Java method call.
And you'll get reflection warnings if that happens.
Yeah.
Right?
It's literally running the same code, so it's, yeah.
But if you specify an precise overload, unless someone's removing that from their API, you wouldn't.
Yeah, I'll say one interesting thing here is that, there was a lot of feedback on this, which was great. It really helped drive our thinking on it. And one thing that we heard really clearly, though, was that there are people who are running in production and never want reflection, right? And that's a really important set of use cases. And we hear you. And we're going to do more in this area. And what we would like to do is, instead of warn on reflect, we would like to have something that's more like error on reflect that gives you a hard error in that case, so that, and the ability to set that from outside the process, which I know is missing right now. And so that kind of combination of things is definitely something we want to do in the near term. So, yeah.
You still allow yourself to limit that to your own application code? 'Cause if,
Figuring all that out is the interesting part. Yes.
TBD.
Yeah. Yes, I've definitely been in that situation. Other questions? Yeah. Tom?
I believe with ad-libs, you can't move a library up a version from what's already there. Is that something that could potentially happen down the road?
No, not easily. The answer is a highly qualified yes, that is theoretically possible. But generally the way that you do that is through the, what do you call them? The agents. So an agent is allowed to do stuff like that. But to do that, you have to set a bunch of JVM flags to install the agent and say it's allowed to attach to itself, and say it's, there's a bunch of caveats to make that work. So we, intentionally put that out of scope. I don't expect that we're going to change that. If you already have a library on the class path, then you're going to have that version until you restart your REPL. So updating versions is not something that we consider in scope for that. Yeah.
So out of all the new features that are coming, whether they're out in alpha or coming soon,
These are all out in 1.12. I'm sorry, this is an old slide. So.
what do you think, in your opinion, is the most overlooked that maybe all of us should be experimenting with if we're not already?
I don't know. Do you guys have an answer? I'm not sure I have an answer to that. I think the one maybe that's the most generally useful is the method values stuff. I think most people have written code that has an anonymous function wrapped around a method invocation. And you can combine that with the functional interface adapters and actually, so for example, if you have an interface that takes a supplier, one very interesting kind of supplier is a constructor. So you can actually pass a class/new for a 0R constructor of a class and pass that into something that takes a supplier functional interface, and it will just call the constructor. And you're actually getting a combination of the method value work and the functional interfaces work then. It's going to generate a Clojure function and then adapt that into the right supplier interface. You see that in some of the stream APIs. There's some that take a supplier for the initial value that you're reducing over, and you can give it a constructor that constructs a new object, like a new vector or something like that, to do that with. So that's a pretty cool use of it. It is possible for us to actually directly adapt and not make the outer function and actually directly adapt the constructor into the place where it's needed, which is what Java does. we've written that code. It mostly is fine, but there are some very tricky edge cases around primitives and things like that. And so we had it in scope several times, pulled it back out of scope several times. In the end, we did not include that stuff, but it's still something we hope to include. And we think there's some ways to actually expand the scope of what we're doing. We're currently restricted just to functional interfaces, but in cases where you're passing a Java method to something that takes a Java SAM interface that's not a functional interface, that's something Java does that we do not right now, but we could support that directly, and that's a case that we could then capture. So it actually expands the scope of what we can do a little bit. So we would like to do that. So we did a lot of diligence to make sure that it was possible for us to add that and still retain all the semantics before we released. And so I think we're confident we can get there, but it's just a lot of fine details. All right, I'm going to be respectful to the next session, so I think we're out of time. But yeah.